In Motion in a Plane, Part 1, we are going to talk about the projectile motion. If we project a projectile, it traverses a path. This is known as the trajectory. Let us put this path in the coordinate axis x and the y. This is the velocity time graph. We project the projectile with a velocity u, which is at an angle theta with a horizontal. We have the components ux and uy. We can also write ux as u cos theta and uy as u sin theta. We have this as a height of the projectile, and this one is known as the range of the projectile. So r is the range of the projectile, h is the height of the projectile, the maximum height. Now let us take the trajectory again and label it at points A, P, B, Q, starting from O. So we have the initial velocity u at an angle theta, ux, uy, u cos theta, u sin theta. At point A, tangentially, we have the linear velocity v. This is the x component ux and the y component vy. Now observe that the horizontal component ux is the same at point A and point O. Similarly, at point P, the vertical component is 0. The horizontal component is ux again. At point B, the direction of the velocity changes, v dash, and again you have the horizontal component ux and the vertical component as vy dash. Similarly, at point Q, you have a velocity component ux and vy double dash. So again, ux, the horizontal component, is same. The angle of projection theta has to be between 0 and 90. We have, according to the law of parallelogram of vectors, if you take point A, then v is equal to root of vx square plus vy square, where vx is nothing but ux. Tan of alpha, if alpha is the angle with the horizontal at point A to be noted, tan alpha is vy upon vx. So we have, since no horizontal acceleration, ax is equal to 0 meters per second, horizontal velocity is constant, ux. We also have vertical acceleration as minus g. So let us talk about the first kinematical equation to find the velocity, v. So v is equal to u plus at, the first kinematical equation. So along the x-axis, vx is equal to ux plus ax into t. So we will have the horizontal acceleration ax is equal to 0, we know. So put the values, we get vx is equal to u cos theta plus 0, that is u cos theta. Now let us take the y velocity, y component vy, that is equal to uy plus ayt, putting it in the first kinematical equation. Vertical acceleration ay is minus g. So vy is equal to u sine theta minus gt. So note these equations for vx and vy. Now let us take the second kinematical equation, s is equal to ut plus half at square. So along the x direction, the displacement sx is equal to uxt plus half axt square. Sx is equal to u cos theta into t, since ax is equal to 0. So t is equal to sx upon u cos theta. Along the y direction, the displacement sy is uyt plus half ayt square. Sy is equal to u sine theta minus half gt square, substituting ay as minus g. So you substitute t is equal to sx u cos theta in this equation, and we get sy is equal to u sine theta sx upon u cos theta minus half gx sx square upon u square cos square theta. So cancelling the terms, and ultimately sin theta by cos theta is tan theta. Therefore, y is equal to tan theta x minus half gx square upon u square cos square theta. This is the equation of trajectory or equation of motion. So we take the equation of motion of the projectile y is equal to tan theta x minus half gx square upon u square cos square theta, and we see that we can write it in the form y is equal to ax plus bx square, where a is tan theta and b is equal to half g u square cos square theta. We can also write it as y is equal to alpha x plus beta x square. This is nothing but the equation of a parabola. Thus, the path or the trajectory of the projectile is a parabola. Now let us take the diagram again and find the time of flight, TF, the total time. So we take the SY equation, the displacement along the y direction. SY is equal to UYT minus half GT square. We know that Uy is U sine theta, T is equal to TF. So Sy is equal to 0 at point Q. So you have 0 is equal to U sine theta TF minus half GTF square. So TF is equal to 2U sine theta upon G. The time of flight TF is equal to 2U sine theta upon G. Now if this is the time of ascent, this is the time of descent, then we can write the time of flight TF is equal to TA plus TD. Now let us find at the highest point By is 0 at T is equal to TA. So the time of ascent can be written in terms of By is equal to U sine theta minus GTA. So TA is equal to U sine theta upon G. So time of descent can be found from Td is equal to Tf minus Ta. And lo and behold, Td is equal to 2u sine theta upon g minus u sine theta upon g, which gives you again u sine theta upon g. So what you observe from equation 7 and 8, the Ta, the time of ascent, is equal to the time of descent. But theoretically, though Ta is equal to Td, neglecting all other retarding forces like resistance due to air, in actual case, Ta is greater than Td. The time of ascent is greater than the time of descent. Now let us find the range of the projectile. We take the Sx is equal to uxt plus half axt square. We put Sx is r, ax is 0, ux is u cos theta, t is equal to tf. And we also know time of flight is equal to u sine theta upon g. Substituting the values, r is equal to u cos theta into tf. R is equal to u cos theta 2u sine theta upon g. But 2 sine theta cos theta is nothing but sine 2 theta. So r is equal to u square by g sine 2 theta. That's the range of the projectile. Now maximum range of the projectile r is equal to u square sine 2 theta upon g is when sine 2 theta is 1, because the value of sine theta is between minus 1 and plus 1 and maximum is 1, where r is maximum. So 2 theta is 90 degrees, theta is 45 degrees. R max is equal to u square upon g. So range is maximum when the angle of projection is 45 degrees. But the actual angle of projection is more than 45 degrees to get the maximum range. Now let us talk about the maximum height of the projectile. So Sy is uyt minus half gt square. We take the y one. So we put Sy as h, height, ay is g, uy is u sine theta, t is equal to ta. From t a time of ascent, u sine theta upon g, substituting in the value h is equal to u sine theta ta minus half gta square. So you get h is equal to u sine theta upon g minus g by 2 u sine theta upon g, which finally will, this is square and you get it, h is equal to u square sine square theta upon g minus half u square sine square theta upon 2g. H max is u square sine square theta upon 2g when the angle of projection is theta. When sine square theta is 1, then H max is equal to u square upon 2g. So that's all for now. Thank you.